Okay, this problem, it's the first one in the lesson, but it is a bit of a doozy. So we'll see how this goes. So you have a ball that's being dropped from 1 meter, I believe it says here somewhere, and it's going to rebound 94%. They talked a little about the physics of that, but then what they're asking is, can you figure out the total distance the ball travels? And so the first thing is, does it give you enough information? Yeah, it starts from 1 meter. So if this is 1 meter height, goes down. When it rebounds, it's going to come back this time 94%, so 0.94 of a meter, and go back again. And the next time it's going to be 94% of that and back. And so the way this problem we'll see as it sets up, it uses a 1 meter separate, but then all of these out here are doubled. So drawing that little picture there helped me a little bit there. So is there enough information? Yes. And then how can you write the general term? So if you wanted just one of these, you would take the initial bounce that was 1, and then you're going to have your rebound amount, the 0.94 to the power of, so each individual term, the first one is 1, but then after that, you're going to have to the first or second or third. On all these problems, if you're stuck at all, go use that question help button up here and either help me solve this or see the example, because all of those really, really give you a real good explanation of what you need to do to solve those. So again, the one we're on right now, so it's to the 1 or 2 or 3, so it's going to be 1 times your 0.94 to the number of bounces that it is would be how much, because you're going to first time multiply by 0.94, the next time you're going to multiply by 94 of that, the next time you're going to multiply by 94 of that, so it just continues. All right, then on to the next part of the problem. So if D is the total distance traveled, and a little bit of, again, the first one is this 1 meter, and then it comes, I'm sorry, it's that one up. By 1 meter is the first, and it's being dropped 1 meter. Then it rebounds to the, on my problem, it's the 94, and it's going to turn around from there and go back. And then this next one is going to be 0.94 times 0.94, and it goes back and it keeps going like that. So you've got your 1 meter out in front, and then you've got 2 of everything else, and everything else is calculated using that formula right there. So you're going to have, as you see, 1 meter and 2 of each of the other terms added up. And then the last thing says, so what's the total distance traveled? So we're just going to plug it into this formula. So we've got my 1 meter drop and 2 times my initial height. A1 was the 0.94. The 0 was my starting height. After one drop, one bounce, it was at the 0.94. And then 1 minus, what was the rate of rebound every time? The 0.94. So if you plug that in and work that out, you'll get your total distance, and it says to round to meters, and I think I just did that on mine, and it came out to 33 1/3. But there's a lot to that first problem of that lesson, but that's how she would work.